All right, guys, welcome to NTI Week 4. This week we're going to look at the inverses of exponentials and logarithms. So when we're talking about inverses of exponentials and logarithms, we're talking about undoing, kind of like we did a couple weeks ago, which is regular inverses. And so here are the inverse properties. Log base b, okay, cancels a base of b, leaving just your exponent. So whenever we have a base of b, we can use a log base b to cancel the base of b to get whatever our x is out of the exponent. And vice versa, what effect does a base of b have on a log base b? Okay, so when I say base of b, this is putting the log base b as an exponent. And so the base of b would cancel your log base of b, leaving you with just x. So very similar to when we have a square root and we have an x squared. What effect does the square root have on the square? It cancels it. And vice versa, if we have a square root with an x underneath it and we square it, what effect does the square have on the x? Okay, it cancels it. And so we looked a couple weeks ago when we were doing inverses of quadratics, and we saw the inverse was a square root function, and we saw that the inverse of a square root function was a partial quadratic. Okay, so you've been using those inverse properties all along to solve equations, and we'll eventually get to that with logarithms and exponentials. We're actually solving them, not just rewriting them. But today we're going to focus on those do and undo properties so that we can break down a logarithm or an exponential equation. So let's look at a couple examples here. This is example 5 in your textbook. So if we have base of 10 log 4. Now, I do want to remind you that when you have a log of x or just log of anything, that is log base 10. Base 10 is the standard, so they don't write it. So when you just see a log without a base, you need to know that that is to be base 10. So what effect does the base of 10 have on the log base 10? It cancels it. So for A, the answer would just be 4. Okay. Now here, what effect does the log base 5 have on a base of 25? Well, you'd think nothing because 25 and 5 are not the same number. But could you write 25 with a base of 5? I'll give you a second to think about it. Okay, so 25 can be written as 5 squared. Okay, so if we rewrote b, we would have log base 5 of 5 squared, and that's going to be to the x, so that is 5 to the 2x, just to make that simpler. Log base 5 of 5 to the 2x. Okay, so the log base 5 would cancel the base of 5, leaving us with 2x as our answer. Okay, so let's look at a few more examples of this. What effect does the base of 8 have on the log base 8? It cancels it, leaving us with just x. Okay. Now, I do want to make sure you guys recognize that this looks like 7 minus 3x if you can't tell the size difference in the font, but this is part of the exponent. And so that is okay to go ahead and do this. There are going to be some other problems later that we can't cancel out unless everything is part of that exponent. Okay, we'll get to that later. So what effect does the log base 7 have on the base of 7? Let's use a different color. Sorry about that. It cancels it. So these cancel, leaving us with a negative 3x is our solution. Now, we're not, and I said solution, all we're really doing right now is simplifying these. So our solution is just the simpler form. This is very similar to example B. So log base 2 can't cancel the 64, but what if we could write 64 with a base of 2? So what could you write 2 to the power of to get 64? And you should have said 6. So this is log base 2 of 2 to the power of 6. and that's going to be 6x now. And so these cancel, leaving us with 6x as our simpler form. Now, ln, if you guys recall, ln is the same thing as log base e. So the natural log is the same thing as log base e. So when you see ln, you need to recall that that is base e. So what effect does the base of e have on the natural log? It cancels. So our answer is just 20. All right, so let's move on to our next examples, and these are basic. I will recall you back to the last video that Miss Shelton made. She was showing you guys the circle method, and in these basic examples, you can certainly use that. In some more difficult examples, you will have to do a couple steps before you're doing that. Now, it wants us to find inverses. If you remember a couple weeks ago, when we talked about finding the inverses of a function, we said the first step was to switch x and y. So if we switch x and y first, okay, and that's not a y, it's an x. At this point, it might be easiest for you just to do that circle method. And so in the circle method, she was teaching you that this here is the base of 6. So since it's an exponential, it's going to become a logarithm. And so you would have log base 6 of x equals y. Okay, that's the circle method. The way that I teach, and so the circle method, you know, this moves over here, and the y basically stays there. The way that I teach this, just focusing on the properties of inverses. So if we have x equals 6 to the y, okay, the way that I teach it is, I want you thinking about how do you get rid of a base of 6? And besides just a trick, because sometimes tricks are hard to remember down the road, you would have log base. So what would you do to get rid of the base of 6? Log base 6. So we would have log base 6 of x equals log base 6 of 6 to the y. And then what effect does the log base 6 have on the base of 6? It cancels. And so we end up with log base 6 of x equals y. Okay? And again, I don't care what method you use. Both methods work. And it might be simpler for some of you guys just to do the circle method at this point. And so you're welcome to do that. All right, so B, our next problem. Again, first step, switch x and y. So x equals the natural log of y plus 3. Okay, so remember, ln is a log base e. So actually, I don't rewrite this out in multiple steps like I did at this point here because it's hard to fit in the log base 6 on the left and right. So what I typically do is just leave this line and put a base of e on both sides. And I wrote those e's extra big because sometimes students don't recognize that those are now bases. And what we had written up here, these highlighted in yellow have now become our exponents. Okay, and so we would have e to the power of x equals, these cancel, and we have y plus 3. Now since we're finding an inverse, we're not done because we need to get rid of, or we need to solve for y. So we subtract 3 on both sides. And so we end up with, sorry, this keeps happening, guys. We would have y equals e to the x minus 3. Now, it's very important that you recognize that that negative 3 is not part of the exponent. It was not on the left when you did the base of e, making the x part of the exponent. So it cannot go into the exponent when you write your inverse. All right, so let's look at some more examples. Pay attention to these two here. They often are confusing for students. You notice they look very similar except for a set of parentheses, which is very important to notice. So again, first step, switch x and y. So we would have x equals log base 3 of y plus 4. Now I alluded to this early in the video. With your circle method, you cannot use it yet. Why? Because everything on the right is not part of the log. It's very similar to if I was doing a problem with a square root and I had, that's a big square root. If I had a square root of x plus 3, I can't square both sides because the 3 is not part of the square root. Okay? And we don't want to square both sides until we get rid of the square root. Or sorry, we don't want, until we get rid of the 3. So you'd have to subtract 3 first. Now, if the square root was all the way over the 3, then we could go ahead and square and then get rid of the 3. So pay attention. Is there parentheses? The only thing that is part of the log is what is directly to the right of the log. Okay, so in this problem, we would need to subtract 4 first. And so that gives us x minus 4 equals log base 3 of y. And now you could use your circle method. You could use what I was showing you a minute ago. I like putting the base of 3 here, just showing the work. And so what that's going to give us is, if I'm right color, the log base 3 is canceled by the base of 3, dropping your y down. And so we end up with y equals 3 to the power of x minus 4. Now you notice that minus 4 was on the left-hand side when you brought the base of 3 to the left. And so therefore it's going to stay in the exponent. Now, that is different than our next problem. So in our next problem, we switch x and y. And just a reminder, at any point in time, if you need to pause this video because you need more time for writing things down, just go ahead and pause. Just trying to keep the videos from being too long for you guys. All right, so can we go ahead and get rid of the log in this problem? Yes. Why? Because the y plus 4 is in parentheses. So everything on the right is part of the parentheses. It's kind of like when that square root has everything underneath of it. You can go ahead and get rid of the square root with squaring. So in this case, we're going to go ahead and get rid of the log by a base of 3 on both sides. And so what that gives us is 3 to the power of x equals y plus 4 because these cancel. And so now our next step is going to be get y by itself by subtracting 4. And so we get y equals 3 to the power of x minus 4. And notice that minus 4 is not part of the exponent because it was not on the left when we did the base of 3. All right, so let's look at a couple more examples. These are some to also pay attention to just because they are written very similarly, but yet they're different. And so we have x equals 2 to the power of y plus 4. Very similar to the last problems. If everything is not part of the exponent, you can't get rid of the base. Okay, so before I can do anything, I have to subtract the 4. And so we get x minus 4 equals 2 to the y. And now you're at a position to get rid of the base of 2. Now in this one, I actually write more, so it might be faster for you to do the circle method here. So I'm going to use a log base 2 to get rid of this base of 2. So log base 2 of x minus 4. And you notice I already put the parentheses there. That's going to be very important to your answer. It's going to be different if you don't have the parentheses. So make sure you're doing that. Equals log base 2 of 2 to the y. Okay? And so the log base 2 cancels the base of 2, leaving us with just y on the right. I'll put it on the left. So y equals log base 2 of x minus 4. And again, you have to have those parentheses, otherwise it's a different answer. And you'll notice that the importance on this next problem. So our next problem, go ahead and switch your x and y. So x equals 2 to the y plus 4. Can you go ahead and get rid of the base of 2? Yes. Why? Because everything is part of the exponent. So it's fair game to get rid of it. So again, you could do your circle method right here where you move your base of 2 to the other side. And then, so that gives us log base 2 of y plus 4. And no, I don't like, that's why I usually don't use the circle method. I'll just go ahead and take the base of both sides, because sometimes it gets confusing when you're having multiple pieces in there. So I would use log base 2 of both sides. Sorry about that, guys. I might have to get Miss Shelton to give me a tutorial on the circle method. All right, so at this point, the log base 2 gets rid of the base of 2, and we have log base 2 of x equals y plus 4. All right, so now we're rolling. All right, so at this point, we're not done because we have to solve for y. So we want to subtract 4 from both sides. Now, this is where we're not going to use parentheses, because nothing on the left, only thing on the left when you took the log base 2 is the x. So the minus 4 is not part of the log base 2, and the way that we show that is by not putting it in parentheses. So our answer to this problem is y equals log base 2 of x minus 4. So the answers look very similar to each other. Okay, the only difference is the parentheses, but that is going to be a big difference in the answers, and so you have to pay attention to that, especially if you're doing a multiple choice assessment. That could be the difference between right or wrong versus if you have a teacher grading your paper and they're looking at that and seeing that it was just a simple mistake versus a conceptual error. All right, so let's practice a few more. These all have more steps. Then I'll have some more for you to practice on your own in a little bit. All right, so switch x and y. Okay, these are very similar to those longer ones that we were doing last week or the week before, when we were finding inverses with square roots and squares and parentheses. So we kind of follow the SAD MEP again. So if I knew what y was, I'd have to add 4, and then you would have to use that as the exponent. Then we would do multiplication, and then we would add 2. So we're going to add 2 first. And I said add 2, but we would have subtracted 2 at the very end. So we're going to add 2 to both sides. So that gives us x plus 2 equals 3 times 2 to the power of y plus 4. And so then we'll divide by 3. So we get x plus, keep messing up on my colors, x plus 2 over 3 equals 2 to the power of y plus 4. Now we're at our point where we can get rid of our base. And so we can do our circle method, or we can do a log, or do the inverse properties. So we would have log base 2. Let's go ahead and write my log base 2's in red, of x plus 2 over 3 and 2 to the power of y plus 4. We know that the log base 2's cancels the y's, and so on the right we're left with y plus 4. Running out of room. So we get log base 2 of x plus 2 over 3, we'll leave it in parentheses, equals y plus 4. We know we have to subtract 4 on both sides, and so that gives us a final answer of y equals log base 2 of x plus 2 over 3 minus 4. And I have the advantage of being able to shrink stuff. So let's do that for spacing purposes. All right, so here's our final answer, guys. All right, let's look at our next one. So switch x and y. Let's go with blue again. So x equals e to the y plus 2 minus 3. And so I'd ask myself, is everything on the right in the exponent? The answer is no. So we're going to have to add 3 to both sides first. So that gives us x plus 3 equals e to the y plus 2. Now is everything on the right part of the exponent? Yes. Is there anything in front of the e? No. So we can go ahead and use a natural log on both sides to get rid of the e. Okay, and so the natural log gets rid of the e, dropping down the y plus 2. And so we have the natural log of x plus 3 equals y plus 2. Subtract the 2 on both sides. And so we get y equals the natural log of x plus 3 minus 2. All right. Let's move on. Again, if you need to hit pause, you can. Switch x and y. So y equals 1/2 log, not x, y, plus 1 plus 2. Subtract 2 on both sides first. And so that gives us x minus 2 equals 1/2 log of y plus 1. Now everything on the right is attached to the log, but you have the 1/2 out front. We want to get rid of that, so we're going to divide by 1/2 because we're multiplying by it. And if you remember from 2 weeks ago, I was teaching you that when you divide by a fraction, it's like multiplying by the reciprocal. So the reciprocal of 2, or of 1/2, is 2. And so what that gives us is 2 times x minus 2 equals log of y plus 1. And since we're doing some multiple choice assessments, I'm going to go ahead and simplify this to 2x minus 4 equals log of y plus 1. Now, remember, when it's just log, you know it's supposed to be base 10. And so we use a base of 10 on both sides. The base of 10 will cancel the log. And again, remember, when I put this base of 10 in red on both sides, when I do this, it makes this and this an exponent. Okay, just to remind you of that, it's not times 10, it makes it a base of 10. And so that gives us 10 to the power of 2x minus 4 equals y plus 1. Looks like we'll have to do a little shrinking here again. Screen likes to shift today. Alright, so our next step is to subtract 1 on both sides, and that gives us 10 to the power of 2x minus 4 minus 1, not part of the exponent. Again, I apologize for that, guys. Equals y. And there's our answer. Alright, and there is no reason why I put the y on the right this time instead of on the left like the other ones. But so either way, it's fine. Alright, last example, and then you'll have some you can practice on your own. Switch x and y. So x equals the natural log of y plus 5. Since there's no parentheses on the y plus 5, we know we need to get rid of the 5 first with subtraction. So we have x minus 5 equals the natural log of y. Natural log has a base of e. So now that became an exponent. This became an exponent because we're using the base of e on both sides. And so what we get is e to the x minus 5. The power of x minus 5 equals y. And so we're done. Okay. I would remind you, I don't have my calculator up, or I'd show you, but in our calculators, we can graph the original We can graph the original on all these. Okay, these are all the originals, not at the same time, individually. But we can graph the originals and compare it to our inverses that we found. And if we compare it to the inverse, we should see in that X and Y table that they flip-flop. If we graph these, they would still all be symmetrical to the line Y equals X. Okay, so if you want to do that to check yourself, go right ahead. Everything should still work out unless you've made some type of error. Okay. Exponentials to logarithms, logarithms to exponentials. These are a few for you to try on your own. Right now would be a good time to hit the pause button. So I'm about to show you all the answers. But if you want to work through these just to make sure that you have it down before you try your online assessments, that would be a good idea. So go ahead and hit pause. All right, guys, I hope you enjoyed this video and hope this helps you out this week. Have a great week.